Hello viewers, in today's class we are going to solve some important problems based on derivatives, right? So in this lecture we are going to solve some important problems which are based on differentiation, and here we'll use some concepts while solving these problems, right? So let us take the problems one by one. So the first problem is if log of x square minus y square over x square plus y square is equal to 2, then we have to find dy over dx at 2 comma 1, right? So here the base of the logarithm is given as 10, right? So we are given this expression and we have to find the derivative of y with respect to x at 2 comma 1. It means this is the value of x and this is the value of y, right? So let us start. So here see, we have to make use of the definition of logarithms here, right? See, if we have a log of say base a, and here we have b and here we have n, then this expression is equivalent to a raised to n is equal to b, right? So these two expressions are equivalent, right? So here if we compare this expression with this one, a is equal to 10. For b we have x square minus y square over x square plus y square, and for n we have 2, right? So now this expression can be written like this, so we can reduce it to this one. So we have 10 square is equal to x square minus y square over x square plus y square, right? So now we have x square minus y square divided by x square plus y square is equal to 100, right? So 10 square is 100. Now here we have in the denominator of 100 we have 1, right? Okay, now here one method is to directly differentiate both sides with respect to x, right? But here we are not going to adopt this method by directly differentiating both sides with respect to x and applying the quotient rule of differentiation to this term, right? So what we will do here, we'll apply the concept of componendo and dividendo, right? So componendo and dividendo says that if we have say a over b is equal to c over d, then a plus b divided by a minus b is equal to c plus d divided by c minus d, right? So here we'll apply this concept of componendo and dividendo to simplify this expression, right? So here for a we have x square minus y square, for b we have x square plus y square, for c we have 100, for d we have 1, right? So let us apply this rule to this one. So we have x square minus y square, then we have plus x square plus y square divided by x square minus y square minus x square plus y square, right? And in the right hand side we have 100 plus 1, because here c is 100 and d is 1, and here we have 100 minus 1, right? So now y square and y square get cancelled, and here x square and x square get cancelled, right? So here we have 2x square, and in the denominator we have minus y square and minus y square, so this is minus 2y square, and here we have 101 over 99, right? So now we can cancel these two, and we have x square over y square is equal to minus 101 over 99, right? So this can be written as 99x square is equal to minus 101 y square, and this is 99x square plus 101 y square is equal to 0, right? So now we can differentiate both sides with respect to x. So differentiating both sides with respect to x, what we will get? This is 99. The derivative of x square is 2x, and here we have 101. The derivative of y square is 2y, and then by chain rule we have dy over dx here, and this is 0, right? So derivative of 0 is 0 here. And now this is 2 9s are 18, 2 9s are 18, and 198x plus this is 2 1s are 2, this is 0, this is 2, and y dy over dx is equal to 0. So now we can write it as 202y dy over dx is equal to minus 198x, and dy over dx is equal to 1 minus 198x divided by 202y, right? So now cancelling these two terms, and we have a minus 99 over 101 times x over y, right? So this is the expression for dy over dx, but here we have to find the derivative of y with respect to x at 2 comma 1, right? So we'll substitute x is equal to 2 and y is equal to 1 in this expression. So dy over dx is equal to minus 99 times x is 2, so we have here 2, and 101 times 1, and this is minus this is 2 9s are 18, 2 9s are 18, and 119 over 101, right? So this is the value of dy over dx at x is equal to 2 and y is equal to 1, right? So now let us take the second problem. So now the second problem is, if y is equal to e raised to 2x, then we have to find the product of these two terms, right? So here we have d2y over dx2, that is the second derivative, multiplied by d2x over dy2, right? So what we will do here, we'll first find out this expression, then this expression, and then we'll multiply both the expressions to get the desired result, right? So let us start. Now see, here we are given y is equal to e raised to 2x, right? So let us differentiate both sides with respect to x. So we have dy over dx is equal to d by dx of e raised to 2x, right? So now the derivative of e raised to 2x is e raised to 2x, and by chain rule the derivative of 2x is 2, right? Because the derivative of x is equal to 1, right? So we have 2 times e raised to 2x, right? Okay, so once we have obtained the value of dy over dx, let us once again differentiate both sides. So what we will get? So we'll have d2y over dx2. So this is the second derivative of y with respect to x, right? So we have d by dx of 2 times of e raised to 2x, and now 2 is a constant here, so we can take it out. So we have the derivative of e raised to 2x, which is equal to 2 times, here we have e raised to 2x, the derivative of e raised to 2x is e raised to 2x, and then we have 2, right? So we have 4 times e raised to 2x, right? So the second derivative of y with respect to x is given by this expression, right? Okay, so now let us find out this expression, that is d2x over dy2, right? So let us again start with this expression. So we have y is equal to e raised to 2x, right? Okay, now here let us take the log of both sides. So what we will have? We'll have log of y and log of e raised to 2x, and we have log of y is equal to 2x log of e, right? So here we must consider one thing in mind, that is the base is the exponential number, that is e, right? So log of y is equal to 2x log e, and log e is equal to 1, right? So here the base is e. So we have log of y is equal to 2x and x is equal to half log of y, right? Okay, so now we have obtained the value of x in terms of y. So now differentiating both sides with respect to y, right? Because here we want to find the second derivative of x with respect to y. So now we have dx over dy is equal to d by dy of half of log y, and see half can be taken outside. We have half and derivative of log y is 1 over y, right? So we have 1 over 2y. So now dx over dy is equal to 1 over 2y, which can also be written as half y raised to minus 1, right? Okay, now let us differentiate both sides again with respect to y, right? So what we will have, see, we have d2x over dy2 and we have d by dy of half y raised to minus 1, right? So now here we have half outside the derivative sign, we have half and y raised to minus 1. So here we'll apply this rule, that is d by dy of y raised to n is ny. We can write it like this, n y n minus 1, right? So here we have minus 1, then we have y raised to minus 2. So this is minus half y square, right? Okay, so the second derivative of x with respect to y is minus 1 over 2 times y square. So now this is equation number 2, and now we have to find the product of these two terms, right? So see, the product of these two terms is now equal to, see here we have 4 times e raised to 2x, because d2y over dx2 is 4 times e raised to 2x, and here we have d2x over dy2 is minus half y square, right? So now let us simplify this expression. So here we have 2 to the 4, so we have 2 times e raised to 2x, and here we have minus 1 over y square, right? And y square can be taken from this expression. So y square is simply e raised to 4x, right? Okay, so now we have minus 2 and e raised to minus 2x, right? Because here 2x and here we have 2x, right? Okay, so we have minus 2 e raised to minus 2x. So this is the desired expression for the product of these two terms. So now let us take the third problem here, right? So here we are given, if 2 raised to x plus 2 raised to y is equal to 2 raised to x plus y, then we have to find dy over dx at 1 comma 1, right? So it means when x is equal to 1 and y is equal to 1. So we have to find the derivative of y with respect to x at x is equal to 1 and y is equal to 1. And we are given this expression, right? So what we will do here, we'll make use of one important result from derivatives, right? See, if we have the derivative of a raised to x, so the derivative of a raised to x is a raised to x log of a, right? So what we will do, we'll differentiate both sides with respect to x. So we'll have d by dx of 2 raised to x plus 2 raised to y, and here we have d by dx of 2 raised to x plus y, right? Okay, now let us apply this rule to this one, because d by dx of 2 raised to x is 2 raised to x, and then we have a log of 2, right? And again applying this rule to this one, so we have 2 raised to y log of 2, and by chain rule we'll have dy over dx over here, right? Because y is a function of x, right? Okay, now let us apply the same result to this expression. So we have 2 raised to x plus y, so the derivative is 2 raised to x plus y, and then we have a log of 2, and then by chain rule we have d by dx of 2 raised to sorry, here we'll have d by dx of x plus y, right? So now let us simplify this expression. Now see, log 2 appears in each term here, so we can cancel it out, right? By taking log 2 common here, we have 2 raised to x plus 2 raised to y dy over dx, and here we have 2 raised to x plus y, and here the derivative of x is 1, and the derivative of y with respect to x is simply dy over dx, right? So now let us simplify it further. See, here we have 2 raised to x plus y, and 2 raised to x plus y is given as 2 raised to x plus 2 raised to y. So here we can substitute the value of 2 raised to x plus y as 2 raised to x plus 2 raised to y, right? So we have here 2 raised to x plus 2 raised to y, and this is 1 plus dy over dx, right? Okay, now we can multiply both these terms. So now if we multiply both these terms, see what we will get. 2 raised to x, 2 raised to x times 1, 2 raised to x, then we have 2 raised to x times dy over dx, and then we have 2 raised to y here, and then we have 2 raised to y times dy over dx, right? Okay, so now we have this expression, and see, if we compare these two expressions here, these two terms get cancelled, right? So these two terms get cancelled, and 2 raised to x also get cancelled, right? So 2 raised to y dy over dx, 2 raised to y dy over dx, both these terms get cancelled. 2 raised to x, 2 raised to x also get cancelled. So here we are left with 0, and in the right hand side we have 2 raised to x dy over dx plus 2 raised to y, right? So now this expression can also be written as 2 raised to y is equal to minus 2 raised to x dy over dx, right? So now we can also write it as dy over dx is equal to minus 2 raised to y over 2 raised to x. So this is minus 2 raised to y minus x, right? So taking 2 raised to x to the numerator, and since the bases are same, so the exponents get here subtracted, right? Because we'll have like this, minus 2 raised to y times 2 raised to minus x, right? So now the derivative of y with respect to x is equal to a negative of 2 raised to y minus x, right? Okay, now we have to find the value of the derivative at this point, that is 1 comma 1. So we'll take x is equal to 1 and y is equal to 1. So we have minus 2 raised to 1 minus 1, so this is minus 2 raised to 0, and 2 raised to 0 is 1, so we have minus 1, right? So the value of dy over dx at 1 comma 1 is equal to minus 1.